Persian engineers across the sea were achieving something that sounds truly impossible. They were manufacturing and storing ice in the middle of 40 degrees Celsius desert heat, more than 2,000 years before the invention of electricity. There were no power plugs, no noisy mechanical compressors, and no chemicals. This was a triumph of pure, elegant engineering and environmental mastery. Step forward and meet the Yakhchal. More than just a building, it was a massive, ancient thermal machine designed to thrive in the harshest climates on Earth. These incredible conical structures were capable of storing up to 5,000 tons of ice, keeping it frozen through scorching summers that lasted 6 months. You see, this wasn't just a simple hole in the ground. It was a precision-engineered thermal battery that defied the very laws of physics known to the ancient world. The intricate process of ice production began in the deep, quiet chill of the desert winter, when the sun finally lost its grip on the landscape. Persian workers would flood long, shallow, and heavily shaded stone pools at night, allowing the water to sit still under the vast open sky. Even in the heart of the dunes, desert temperatures can plummet below the freezing point once the sun sets, a phenomenon the Persians used to their advantage. By the early hours of the morning, the liquid water had transformed into a thin, brittle sheet of crystal-clear ice, sparkling in the low moonlight. Teams of workers would quickly harvest these precious frozen sheets, rushing them into the safety of the Yakhchal before the first morning ray of sun could touch them. Every morning was a high-stakes race against the rising sunrise. Any delay meant the desert heat would reclaim the ice before it could be stored. However, storing the ice is only half the battle. Keeping it frozen through a 100-degree summer is where the true genius of Persian architecture is revealed. The secret lay within the walls. They were built up to 6 feet thick, providing a massive thermal mass that acted as a barrier against the external heat. To achieve this, they didn't use standard brick. They used a sophisticated, legendary mortar called sārooj, a material specifically engineered for insulation. The base of this ancient composite was a carefully balanced mixture of local sand, thick clay, and lime, all sourced from the surrounding environment. But then, the engineers added the unexpected sticky egg whites and goat hair. These fibers provided tensile strength and increased the mixture's density significantly. Finally, they blended in ash. Once dried, this created a rock-hard, heat-proof barrier that was virtually impenetrable by the outside thermal energy. This ancient supermaterial was also completely water-resistant, ensuring that no moisture could seep through the walls and compromise the internal temperature. It was a masterpiece of chemistry, blocking heat transfer more effectively than almost any other building material available in the ancient world. The domes themselves were architectural wonders, standing 60 feet tall and cutting a sharp, conical silhouette against the flat desert horizon. This specific shape wasn't chosen for its beauty or aesthetics. Every curve and every angle served a vital purpose in the management of air. The fundamental laws of thermodynamics dictate that hot air always rises. The Persian engineers understood this principle perfectly and built their domes to exploit it. They strategically placed a small opening or vent at the very peak of the dome, allowing the structure to breathe out the unwanted warmth. As the lighter hot air escaped through the top, the heaviest and coldest air remained trapped at the very bottom, where the ice was stored in deep pits. This created a continuous, natural convection cycle. The building was essentially cooling itself 24 hours a day without a single moving mechanical part. But even with thick insulation and smart shapes, the 40-degree heat was relentless. To fight back, the Persians looked toward the wind. They integrated massive towers called badgers or wind catchers. These served as the lungs of the cooling system, reaching high into the sky to grab moving air. These towers were usually positioned on the north side of the structures to capture the coolest possible breezes while remaining shaded from the direct sun. The towers acted like funnels, catching the wind and forcing it downward into a series of sophisticated underground channels and tunnels. These channels ran deep beneath the earth, traveling directly under the ice storage chamber to provide a constant source of ventilation. Because they were buried, the earth itself acted as a massive heat sink, cooling the incoming wind to a manageable temperature before it ever touched the ice. To push the cooling even further, some Yakhchāls were connected to qanats. These were a vast network of ancient, man-made underground aqueducts. These qanats brought fresh, cold water from distant mountain springs, traveling miles through the dark earth to reach the desert settlements. As the wind from the Badgirs passed over this flowing water, it triggered a process known as evaporative cooling, which naturally siphons heat away. This is the same principle as sweat cooling your skin. As the water evaporated into the airstream, it pulled thermal energy out of the environment. This clever interaction could drop the temperature inside the storage chamber by several degrees, keeping the environment significantly colder than the outside air. It was a complex, multi-stage cooling system that utilized wind, water, and earth, all designed over 2 millennia ago. By midsummer, the Persian desert becomes a furnace, with the sun beating down so hard it can feel like a physical weight on your shoulders. But step inside the Yakhchal and the world changes instantly. It was a silent, dark winter wonderland where you could see your own breath in the air. Ice was a luxury beyond measure. Wealthy merchants and nobles would pay absolute fortunes for just a single cup of this precious frozen gold. They didn't just use the ice for cooling drinks, they used it to create the world's first sophisticated frozen culinary treats and delicacies. This led to the creation of faluda, a delicious mix of starch noodles, rosewater, and lime. It is arguably the world's oldest frozen dessert. It is truly incredible to imagine. While the rest of the world struggled with the heat, Persians were enjoying ice cream in the year 400 BCE. This mastery of the climate wasn't a result of luck or trial and error alone. It was the product of incredibly advanced mathematics and geometry. The Persian engineers were masters of fluid dynamics long before the term was even coined, understanding exactly how air and water behave in motion. They possessed a deep, practical understanding of specific heat capacity, knowing exactly which materials would hold the cold and which would repel the sun. Even the orientation and the specific slope of the dome were calculated to reflect the maximum amount of solar radiation throughout the day. Consider this. A modern high-tech refrigerator is lucky to last 15 years before it ends up in a landfill. Our technology is often temporary. Yet many of these Yakhchāls have stood firm for over 2,000 years, outlasting the empires that built them and the generations that used them. They have survived devastating earthquakes, brutal wars, and the slow eroding passage of time, yet their stone and sārooj walls remain intact. To this day, you can still visit these giants in cities like Yazd and Kerman, where they stand as silent witnesses to a forgotten age of brilliance. They are much more than just ancient ruins. They are functional monuments to human ingenuity and our ability to harmonize with nature. We often have a habit of thinking of our ancestors as primitive or limited by their lack of modern tools. But the truth is often the opposite. The Persians conquered one of the most hostile environments on the planet using nothing but the basic elements: earth, air, and water. There was no carbon footprint, no mechanical noise, and no pollution. Just the sound of the wind and the deep, enduring cold of the stone. Perhaps these ancient technologies hold the key to our own sustainable future as we look for ways to cool our world without destroying it. Cooling the world doesn't always require a massive power grid or complex chemicals. Sometimes, it just requires a smarter way of looking at the sky. It requires a deep, fundamental understanding of the laws of nature and the patience to build something that lasts for millennia. That is the enduring 2,000-year-old secret of Persian ice, a testament to a time when humans truly mastered the heat of the desert. Thanks for watching.